In this video, we're going to look at solving systems of equations. So normally you have one equation, one variable, namely x, you solve it. In this case, we have two variables, x and y, which means we need two equations to solve. How many ever variables you're solving for, you must have that many equations in order to solve them. In this case, it's x and y, we have two equations. So we're going to call the first equation A and the second equation B. The first thing that you want to do to solve a system of equations is choose one of the variables. You want to solve one equation for one variable. You have a choice, it doesn't matter which one. Sometimes it's easier to use one over the other. So I'm going to choose equation B. I'm going to take equation B and I'm going to solve it for x by adding y to both sides. So I get x equals 2 plus y. All right. Secondly, you want to substitute the new expression that we just found into the other equation. So in this case, we take x as equal to 2 plus y, and we have to use a because we use b in number 1. So I take my a equation, which is x plus y is 4, and I replace the x with 2 plus y. Third, you want to solve for y. Okay, so now we want to solve for y, or whatever variable. Solve for the variable in step 2. So we have 2 plus y equals 4. 2 plus 2y equals 4. So we subtract 2 from both sides. 2y equals 2. Divide by 2, y equals 1. So we found our first variable, y equal 1. The fourth step is to back. Okay, I am not sure what's happening with my screen here. Let's get rid of that. Come back here. Okay, we want to back substitute step 3 into the first equation used. So you go back to number 1, right? And in number 1, we used equation B. So I'm going to take equation B, which I found to be in step 1, x equals 2 plus y. Well, now I know y is 1, so I can make this 2 plus 1, x equals 3. So here's my answer, x equals 3 and y equals 1. Now, when you do these problems, you always want to check that you solved them correctly. So what that means is you would take this 3 and this 1, you would plug it back up in here into the original equations and see that they work. So if I put 3 and 1 in the first equation, I'm going to have 3 plus 1, which is 4. So it's correct. And I would have 3 minus 1, which is 2. So again, that's correct there. Okay, let's take a look at another example. We have 3x squared plus 4x minus y equals 7. And 2x minus y equal negative 1. Okay, so first I'm going to choose equation B because it is a simpler equation. It doesn't have a square in it, so it'll be easier to solve. And I'm going to solve it for y. I'm going to subtract 2x from both sides. And then I'm going to divide both sides by negative 1. So on the left I'll have y, and then this negative 1 has to be distributed to both of these terms, so I'll have 2x plus 1. Now I'm going to take my second equation, 3x squared plus 4x minus y equals 7. And I'm going to substitute this in place of y. So I'll have minus 2x plus 1 equals 7. Notice I put that in parentheses because the minus does apply to the whole thing, right? So then I solve. So I'll have 3x squared plus 4x minus 2x minus 1 equals 7. Or 3x squared plus 2x minus 1 equals 7. Then I'm going to factor this. If you example of how to do that. So you'll have 3x minus 4 and x plus 2. No, because I made a mistake. Before we can factor, right, we have to get a 0 on the right. So this 7 we have to move over, right, to get a 0, or the factoring really doesn't do us any good. So we have minus 1 minus 7, and then 7 minus 7 is 0. So we actually have 3x squared plus 2x minus 8 equals 0. Now we can factor into what I said. That would be 3x minus 4 and x plus 2. Now we can set each factor equal to 0 because we do have the 0 over here. So on this one, we subtract 2 from both sides and we get x equal negative 2. We add 4 to both sides and we get 3x equal 4. Divide by 3, x equal 4/3. So in this case, there are two values that make my x true that would work. X can be negative 2 or x can be 4/3. That means that we're also going to get two y values. So make a note of this, right? Y equal 2x plus 1. Well, I might have room to the side. We have to, for step 4, right, we have to put these values in this equation. So I'm going to have y equals 2 times negative 2 plus 1. So y equals negative 4 plus 1, or y equal negative 3. What that means is that my x, negative 2, and y of negative 3 is a solution to this set of equation. It's a point. It's an x value and a y value. Now I have to do the same with 4/3. I'll have y equal 2 to the 4/3 plus 1. Y equals 8/3 plus 1. Get a common denominator, right, of 8/3 and 3/3. And I'll get 11/3. So 4/3, 11/3 is also a solution, right? We have two answers. We have this point and this point. So when you find 2 points like that, what that means is these two, the graphs of these two equations intersect at those 2 points. So the top equation is going to be a parabola of some sort. A parabola, something that opens up like that. It's that kind of shape. And the bottom equation is a line. So those two things, when you graph them, intersect at 2 points like that. What we're doing is we're identifying what those 2 points are when we solve. So we're going to look at one more example of what can happen when you solve these types of problems. So basically when it says solve for x and y, you're also, that is the same thing as finding where the graphs of those equations intersect, where they touch each other. So in that case that we just looked at, they touched each other, they intersected in 2 points. This next case that we're going to look at, we have negative x plus y equal 4 and x squared plus y equal 3. So again, we have a parabola and a line. If we take the first equation here, A, and solve for y by adding x to both sides, we'll get y equals x plus 4. Then we put that into B. So we'll have x squared and y becomes x plus 4 equals 3. Then in the third step, we are going to solve, wait, that should be equals 3. Okay, now we're going to solve for x, right? So we're going to subtract the 3 from both sides, and we're going to get plus 1 equals 0. Now, if you try to factor this, what you will discover is that it will not factor. There are no numbers that will multiply to give us 1 and add to give us 1, right? That's the question we're asking when we factor. So we actually have to use the quadratic formula. So if you need a review, a refresher on that, you can go back to the chapter where we solved quadratics and see that. But I will give you the quadratic formula, remember, is, I'll write it up here. No, not x squared, just x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are the numbers in front of, or the coefficients. That's what we call those numbers, right? So in this case, a, b, and c are all 1. So we just have a bunch of 1s. So we have negative 1, that's what b is, using this formula here. B squared will be 1 squared minus 4. A is 1, C is 1, all over 2 times 1. Well, if we simplify that, we get the square root of 1 minus 4 over 2, or negative 1 plus or minus the square root of negative 3 over 2. Well, you should remember that when you have a square root of a negative number, that's imaginary, right? It's not a real number. So what happens in this system of equations is that there's actually no real solutions. There are no numbers, no real numbers that meet this criteria, right? That you can put in there and it be true. So if we were thinking about the graph of those two, what that means is that we have a parabola, some sort of parabola with this second equation here, right? Like we drew before. It's a curve like that. And then our line floats somewhere below it, so they never actually intersect. So in that case, you get no real solutions.